So this next mini unit, we're going to look a little bit at fractions. So this section 3.1 kind of just starts out with some basics, some kind of discussion about fractions, different things you can do with them. Then we'll look more at the algebra, so adding and subtracting, multiplying, dividing. So let's see, it says write 1/2 with a denominator of 6. So right now my denominator is 2. Okay, so in order to get a denominator of 6, I would have to multiply, I'd need to multiply by a 3 in the denominator, right? Because 2 times 3 is 6. Now, in order to not actually change the value of the fraction, I'd actually have to put the same number top and bottom, because if I do that, I'm actually just multiplying by 1 here. Okay, so I can do that without actually changing the value of the expression. I'm just making it look different. Okay, so then 3 over 6. So 3/6, this is how I would write 1/2, but with a denominator of 6. So my next one, 2/3. Let's see, I want a denominator of 12. So I'd need a 4, right? 3 times 4 is 12, but I have to put the same number top and bottom because, again, I'm really just multiplying by 1. So not actually changing the value, I'm just changing how the thing looks. Okay, so I multiply straight across. Oops, so I have 8 over 12. So 2/3 is the same as 8/12. Write 17/10 with a denominator of 20. Okay, so I'd have to multiply by 2 over 2. 34 over 20. This one's more interesting. Write 3 with a denominator of 2. So right now, 3 is an integer. It's a whole number. So 3, what is its denominator then? Its denominator is implied to be 1. 3 itself is just 3 divided by 1. So if I want a denominator of 2, I'd have to multiply by 2 over 2. So that's kind of interesting. It makes sense. If I want to write 3 with a denominator of 2, it'd be 6 divided by 2, right? Because 6 divided by 2 is 3. Write the fraction in lowest terms. So when we say write the fraction in lowest terms, we could also say reduce the fraction, like cancel any common factors. Okay, so if I'm looking at 15 over 18, I might want to start by breaking up 15. Like I know 15 is 5 times 3. I know 18 is 6 times 2. I can even keep breaking these all the way down into their prime factors, like this, say. And then I can look for cancellation, so my 3's cancel. So what I'd be left with is 5 over 4. I think I made a mistake in that one. Do you see my mistake? I'm always looking and double checking as I go. I think it's right here. So we have to fix this. Let's fix it. What was my mistake? Well, 15 is 5 times 3. 18 is not 6 times 2, though, is it? 18 is 6 times 3. So if we make a mistake, it's a good idea to just erase all the way back to the mistake. That way, it doesn't get confusing. Okay, that looks better. Can cancel 3's. 5 over 6. Let's start breaking down 36 over 48. So you just start with something. So I know 36 is 6 times 6. I know 48 is 24 times 2. And then I can just keep on going. So 6 is 3 times 2. And then 24 is 6 times 4. Top's already broken all the way down into prime factors. 6 is 3 times 2. 4 is 2 times 2. All right. Then let's see what cancels. 3s, 2s, 2s. So it looks to me like we're left with 3 over 4. Okay, let's see. 12 is 4 times 3. 40 is 10 times 4. It's 2 times 2 times 3. 5 times 2 times 2 times 2. 2s. Another set of 2s, and looks like that's it. So I've got a 3 in the numerator and a 10 in the denominator. 9 is 3 times 3. 30 is 10 times 3. Break that all the way down. Let's see 3's go, and I guess that's it. 3 over 10 again. So that's kind of interesting. So do you notice that 3 and 4 are actually equivalent fractions? So that's kind of cool. So if I was looking at, 12 over 40 and 9 over 30, it's not immediately clear that those two fractions are actually equivalent. Okay, but once I reduce them or I write them in lowest terms, I can actually see that they're both equal to 3 over 10. So that's pretty cool. So actually those two fractions are equal. And so that's just a side note. This is kind of scratch work. Okay, we can reduce fractions where we have variables as well. 6x, well, that's 2 times 3 times x. And 9 is 3 times 3. Cancel a set of 3's. So that's 2x over 3. Let's see, 38. What's half of 38? That's 19? I think 19 is prime. So with this one, it might be helpful to even break up the x, because x cubed is x times x times x. Breaking that up into factors. 18 is, let's see, 9 times 2. So that's 3 times 3 times 2. Okay, so what cancels? X's, 2, and a 2. So 19x over 9. Insert the inequality symbol less than. Remember what these mean? This one was less than. This one was greater than. Insert the appropriate inequality symbol to make a true statement. So the question is 5/3, this is the last one for this section, is 5/3 less than 8/3 or more than 8/3? Well, that one's easy. I mean, I have the same denominator. So 5/3 is less than 8/3. That's easy. But what about the next one? What about 2/5? Is 2/5 more than 1/4 or less than 1/4? So in order to compare these, I'm going to have to make a common denominator. So if I'm looking at 2/5 and 1/4, the common denominator is going to be 20. Because I have to be able to take 2/5 and multiply it by something, and 1/4 and multiply it by something, so that these guys will both end up with the same denominator. So I would have to multiply by 4/4 here and 5/5 here, because that way I have 8/20 and 5/20. You see how now I have the same denominator? So asking the question I'm asking over here is really the same as asking, let's see, 2/5 was 8/20, 1/4 was 5/20. Now I can compare. 8/20 is more than 5/20. So that means 2/5 is more than 1/4. Do the same thing with number 3. So I have to come off to the side and I have to look at making a common denominator. So that means I'm taking each of those fractions and I'm multiplying. Let's see, 6 and 8. So what is the common denominator going to be? So multiples of 6, 6, 12, 18, 24. Multiples of 8. So I'm looking for matching, right? Look, 24 will work. That would be the least common denominator. So I'd have to multiply by 3/3 here and 4/4 here. Okay, so let's see, -5/8 was -15/24. -5/6 was -20/24. Okay, so -15 is more than -20. Okay, so -5/8 is greater than -5/6. So this is really my scratch work. And one more. Okay, so let's see, I'm going to need a multiple of both 10 and 13. So I think that's going to have to be 130. So 2/13, if I multiply by 10/10, and 3/10, multiply by 13/13. Okay, so 2/13 is 20/130. 3/10 is 39/130. 20 is less than 39. And there we have it.